limits of acceptable differential settlement for different types of structures. What is 1 over 100? 100 is the horizontal length between the two foundations, for example, and one is the difference in the settlement. So if two foundations are 100 feet away, 1 by 100 means there is 1 foot of difference in their settlement, right? And if you come to the extreme right, so it is the the distance between two foundations is 900, and the difference in their settlement is only 1 feet. So it means that as you go towards the right, the criteria become very strict, very strict. 1 over 900 is very strict criteria, and this one is used for uh, like this one, 1 over 700, 1 over 800. This, the middle one is 1 over 750. So this is the limit of where difficulties with machinery sensitive to settlement are to be feared. It means that if you are going to design a foundation for a machine, the limit would be this one or less than this on the right, but it should not be on the left side, because if the differential angular distortion is more, there would be misalignment of the machinery parts, and there would be wear and tear and misfunction of the machinery. 1 over 500 or less is the limit for buildings where cracking is not permissible, and 1 over 150 or less is the limit where considerable cracking in panel walls and brick walls are allowed, right? So you can use this chart to design or check your foundation angular distortion. So this is the end of this chapter. If you have any problem, you can ask. Otherwise, we would move on to next chapter. Not last, but the major chapter, which is called piles. I hope you are aware of piles. Do you have any idea what piles are? Can anybody define or know what piles are or have seen? जी, कोई बैठा भी हुआ है लेक्चर सुनने के नहीं, सिर्फ लॉग इन हुए हो?
सर जी डीप फाउंडेशन जो प्रोवाइड करते हैं इन्हें पाइल्स कहते हैं.
अच्छा, गुड, ठीक बात है. पाइल जो है, in this figure you see this is a very ideal and favorable situation for piles. This is a building, probably a large building, and below the building foundation there is soft soil. So if you construct a shallow foundation, it may lead to huge settlement. But luckily, not very far from the surface, you have a firm soil. So why not build piles and rest them on the firm soil, right? And derive maximum of the resistance from the firm soil to resist the building. So this is one of the favorable situation where piles are used. Piles can take lateral loads, lateral wind loads as well, right? In addition, they could be used under the machine foundation where we can control the vibration, or they can be used where there are nalas, rivers, right? Nalas or rivers under bridge foundation which leads to scouring. So if you provide a shallow foundation, the scouring can cause erosion and the foundation uh, would be undermined. So in that case, we provide piles so that if any there is some erosion, no problem. There is sufficient land embedded into the soil, which gives you the capacity, right? Piles can also be used to densify the loose sand deposits. जहाँ पे आपके पास लूज सैंड डिपॉजिट्स हों तो आप उसमें पाइल्स को ड्राइव करें, जिस तरह नेल को ड्राइव करते हैं ना जमीन में, इस तरह पाइल्स को ड्राइव करें तो वो सारा सैंड जो है ना वो कंपैक्ट हो जाएगा। फिर उस कंपैक्शन उसकी कैपेसिटी और कम वो बढ़ जाएगी, तो आप उसके ऊपर फिर बिल्डिंग बना सकते हैं। सो दीज आर डिफरेंट यूजेस, ठीक है ना। अच्छा, यहाँ पे भी जहाँ पे बेसमेंट्स हों, deep basements or water table is high, so when there are deep basement and deep basement are below the water table, the water has the effect of uplifting. They would try to uplift the building and destabilize it. If the weight of the structure is huge, then there is no problem. But if the weight of the structure is marginal, right, so it could destabilize. So in that case, we provide piles underneath the foundation, right? And they would not support the weight of the structure, rather they would prevent them from the building from going up, not from going down. So the purpose of the piles would be different. Classification of pile according to the mechanism of load transfer. Here you see we have three types of piles: end bearing pile, friction pile, and friction cum end bearing pile. The first pile, which is called end bearing pile, इसमें आप देख सकते हैं the soil surrounding the soil surrounding the pile is soft ground. It's soft soil. If this is soft soil, so no friction resistance, almost zero friction resistance or skin friction. But at the base there is hard soil, so there much of the resistance. So in your calculation, so these are called end bearing piles because the resistance is coming from the end of the pile, end bearing from the pile, not from the side friction resistance, right? So in your calculation, you can ignore the side resistance and only rely on the end bearing. On the other hand, if you don't have any hard stratum at the end and you have soft to firm soil around the pile, so in that case, you can, on the contrary, ignore the end bearing, right, and rely only on the skin friction from the sides. And if you have situation where you have firm soil around the pile and also have a firm or hard soil at the end, right, so you have both resistances, friction resistance or skin resistance from the sides, and at the base, right, a resistance, huge resistance, right. So these are called friction cum end bearing pile because friction resistance is there and end bearing resistance is there. So this is the classification of piles according to how they derive their resistance from the soil. अच्छा जी, फिर है classification of piles according to their method of installation. Primarily, we have two ways to build or install a pile. Number one is driven or displacement piles. In this type, what we do, like steel piles, we bring them to the site and we hammer them down into the ground, or jack them or screw them, right? Or we build concrete piles and bring them to the site and then hammer them down, right? These are called driven piles. They are driven. They are also called displacement piles because when you drive them, they displace they displace the existing soil to make a place for themselves, right? The other type, which is more common in Pakistan, are called board or replacement piles. ठीक है ना? Board or replacement pile में क्या होता है? In board piles, we make a borehole equal to the diameter and length of the pile, then put steel bars into that borehole, and then we concrete them on the site, and then let them harden, and then we put load on it, right? So these are called board piles. They are also called replacement piles because you replace the soil, you remove the soil, replace it with concrete. It takes more time. Board piles require more time to build as compared to driven piles. But driven piles have the problem that it creates noise, vibrations, and some environmental problems. But driven piles are more common in advanced countries, and board piles is more common rather in Pakistan. Here are some figures of different types of piles according to how they are built. This is a square pile. At the end, there is a point. They are pointed. They are driven into the ground. They are driven piles. This is steel H pile. The top is cross section of the pile, and this is long section of the pile. This is also a driven pile. In this, a steel tube is driven. There is a shoe down there, and the hole in the steel pipe pile is filled with concrete at the site. Though concreting is done at the site, yet it is called a driven pile because you have actually driven the steel pipe. This also first you drive a tube, a steel tube pile, and then you put concrete, and then you withdraw the steel pipe pile. So this one results. This one is a circular concrete pile, but this is a board pile because you have made a borehole and then you have put in concrete. This is also, the last one is also a board pile, with the difference that the end of this is enlarged. It is called under-reamed pile. The reason you have enlarged the base because you have firm soil here and you want to increase the area of the base of the pile so that maximum of the end bearing resistance you can achieve. Then you have classification according to the materials of piles. Timber piles are used, but of course they cannot take more load, and the splicing, if you have you require longer piles, the splicing would be a bit difficult, right? This has disadvantage that if they are above water table, they could be affected by insects, right? But if they are below water table, then the insects would not harm them. Steel piles, they can take much more load, and they could be of any length. They could be easily spliced. They could be HP piles, pipe piles, or closed end piles, different types. They are easy to splice, high the capacity, small displacement. ठीक है ना? एक उसमें डिसएडवांटेज है कि वनरेबल टू कोरोजन है, ठीक है ना, वनरेबल, और एचपी सेक्शन में बी डैमेज डिफ्लेक्टेड बाय मेजर ऑब्स्ट्रक्शन। अगर कोई ऑब्स्ट्रक्शन दरमियान में आ जाए तो ये डिफ्लेक्ट हो सकता है। कंक्रीट पाइल में दो किस्म के हैं, एक तो वहाँ इंस्टीट्यूट पे कंस्ट्रक्शन होती है और दूसरी प्री कास्ट पाइल होती है, ठीक है ना। प्री कास्ट concrete piles may be made using ordinary reinforcement or they may be pre-stressed. Pre-cast concrete piles हैं वो एक तो आम, इसमें आप reinforcement डाल लें फिर concreted कर लें, जब वो harden हो जाए you pick them with a crane and bring it to the site and then drive them. The other could be pre-stressed. What does it mean by pre-stressed? You use pre-stressed cable and stretch them, and then when they are stretched you put concrete, and when they harden you cut the pre-stressed cables, so they apply a compressive force which would enhance their capacity, right? And then you pick them and bring them to the site and drive them. They could be of different lengths and have different capacities. Usual condition are 900 kilonewton for precast and 8500 kilonewton for pre-stressed piles. Disadvantage: difficult to handle unless pre-stress. अगर ये आपने pre-stress ना किया हो तो it's a bit difficult because when you pick them, and the picking would cause different moments, bending moments in them. Pre-stressed piles are difficult to splice. Disadvantage of concrete piles: concrete piles are considered permanent. However, certain soils, usually organic, contain materials that may form acid. So the soil that you are going to put your pile in must be tested. That soil must be tested for different aggressive materials, chemicals that are present, and accordingly you treat the soil, or you use a special kind of cement in your pile construction. Composite piles could also be used, but they are very, very rare, in which one material at the bottom and other material at the top, like timber, below the water table, and above you use steel or concrete, but they are very rare. So this is about the types of piles according to the mechanism, how they derive their resistance from the soil. They could be classified as friction piles, end-bearing piles, end-bearing cum friction piles. And according to the way of installation, they could be classified as driven piles or boat piles, or according to the material, they could be timber piles, steel piles, or concrete piles. Load carrying capacity of piles. This is the major theme of our this chapter, in which we would find the capacity, load carrying capacity of piles. ठीक है ना? There are four methods that we would be discussing. Static analysis, we would discuss in this chapter at much more detail. Dynamic analysis, we would briefly discuss. Load testing, we would discuss, and correlation with field test, we would discuss in this chapter. So first, let's discuss dynamic analysis very briefly. They are used for driven piles. What we do, very simply, you have a hammer of weight W. They have free fall of height H, W into H. This is the energy that you input to the pile that you are driving into the soil. You want to drive a pile into the soil. You have put a hammer. You have brought a hammer, which has a weight W. You throw them from some distance with a free fall distance h. W into h is the energy that you are giving to the pile, and as a result, the pile advances into the soil, right? So you want to find the capacity of the load carrying capacity of that pile. So energy input would be equal to energy used plus energy lost. Energy input is equal to weight into h, weight of hammer into free fall. Energy used will be equal to Pu into S. S is the penetration or advancement of the pile, and Pu is the resistance of the soil or the capacity of the soil, right? Pile. Pu is the resistance offered by the soil to that penetration S. So Pu into S is the energy used by the pile plus energy lost. So this is very basic equation for dynamic pile formula, in which you equate energy input to the energy used plus energy lost. Energy lost is due to the rebound of the hammer, right? Elastic compression of the pile, of the soil, generation of temperature, heat, right? All of these are the energy losses. And based upon how you are taking this energy loss into equation, there are a number of equations for dynamic formulas, all of them varying because of how they tackle energy lost. There are 100 of them, and they would result, if you use them, they would result in different pile capacities. You see, if, okay, so WH, W into H if you put here, and Pu into S you put here, plus energy loss. If you know the energy loss, you can find the Pu value, which is the ultimate capacity of the pile, right? So as I said, there are many equations they have resulted in the literature because of this energy loss component. But all of these equations have one assumption at the core, which is that the input energy and energy use occurs with no time lag. As you hammer this, as you drop the hammer on the pile, simultaneously at zero time lag the penetration occurs. While this is not the case, because when you drop the hammer, there is a stress wave that generates, that travel down the pile and then rebound back this. So there is a time lag. This principle is taken up by wave equation analysis. This is another approach to the dynamic pile formula, which takes into account the propagation of waves, stress waves into the pile due to the hammer, and give you the capacity of the pile, right? But we are not going into detail in any of these equations. Pile driving equipment, how we drive a pile into the soil using different equipment. The simplest one is called drop hammer. अच्छा जी, drop hammer. Drop hammer is the simplest one. You have a hammer, you drop them from some distance on the pile, right? And it results into the penetration of the pile into the ground. That's called drop hammer. Single acting hammer is an advancement to the drop hammer in which you do not you have a stream or compressed air to lift the hammer up, and once it reaches to the peak point it drops from there on a free fall, right? Again here the energy input is the weight of the hammer into height of fall. The advantage here though is this, that the hammer is lifted up by stream or compressed air. Double acting hammer has another advantage. In this, stream or air is used to lift the ram or hammer up, and then you use stream or air to drop the hammer. So it has much more energy. It has much more energy because of this stream or air pressure, right? So the advantage here between drop hammer, single acting hammer, and double acting hammer is the headroom. Because for drop hammer and single acting hammer, you need headroom. If you are working under a bridge or inside a building, you don't have a headroom, right? So double acting hammer requires a small headroom for, because you don't have a free fall, rather you have an air or steam pressure. Diesel hammer. In this hammer, what you do, first you lift the hammer up and you drop it down. You raise the hammer up manually and drop it down. But the moment it reaches to the bottom, right at that moment you inject fuel, right? The fuel is compressed, right, and ignited, and an explosion occurs. Due to that pressure, two things occurs. Number one, because of that explosion, the pile is driven down, and because of that explosion, the hammer is automatically lifted up. So though you have started the operation manually, it gets automatic itself. So the explosion lifts the hammer up, and when it drops down, you repeat the cycle. You inject the fuel, they are compressed, explosion occurs. As a result, the pile goes down, the hammer lifts up. So it's quite automatic. But when you have a soft soil, then there is problem. Because when their explosion occurs, all of the energy is used to penetrate the pile down, and you have no energy in the system, right? No reaction is offered to the hammer to lift itself up. So the operation ceases, stops, and you have to manually start again. You have to manually, and over, this comes over and over. So you have to have a good experience, and you should know the soil profile before using diesel hammer. Vibratory hammer is through vibration. It imparts vibration to the pile, and by this vibration, the pile goes down. But remember that it's good when you don't have any headroom, right? It also has less noise pollution. Vibratory hammer. These are sections of this single acting hammer, right? This double acting hammer. ये देख रहे हैं कि अब भी ऊपर और नीचे दोनों की तरफ से आपको स्टीम मिलेगी और एयर. ये डीजल हैमर है, और ये आपके पास वाइब्रेटरी हैमर है, वेयर देयर आर एक्सेंट्रिक मासेस which move in circular direction, in opposite direction, and they impart vibration to the pipe. So this was all about driven piles. Dynamic driven piles or dynamic pile formula. Now we come to the static pile formulas, right, which we would discuss is much more detail and solve example on them. ठीक है ना? So let's discuss static pile formulas. Let me snipe this for you. देखें, this is a pile. On top of this, a load equal to the ultimate capacity of the pile is applied, which is PU, ultimate load carrying capacity of the pile. This is resisted. This, in addition with the weight of the pile, is resisted by the skin friction, or which is QS, which is represented by QS, and the bottom at the bottom it is represented by QB and bearing resistance QB. So if you want to write an equilibrium equation, PU plus WP would be equal to QS into AS. QS is the skin resistance, AS is the area on which it is acting, QB is the end bearing resistance, AB is the area on which it is acting, right? So this is the equation that you can use to find PU. QS is the skin resistance. ठीक है? AS is the perimeter area, which is equal to pi B, which pi into D. Pi into D is the perimeter, into L is the length of pi. Pi dl. Agar if you have a circular footing, if you have a circular pile, but if you have a square pile, then AS would be equal to B by B for a square pile. नहीं, गलत है. Would be equal to 4B. 4B is the perimeter, L is the length. QB is the end bearing resistance, AB is the end bearing area, and this would be equal to pi by 4 into D square. For circular, and for square it would be equal to B by B for square. Okay. For square pi, the cross section of which is square. B by B. Okay. So this is the equation. What I do, I subtract WS effective weight of the soil. Ws is the effective weight of the soil removed by pi. Soil की construction की वजह से weight of the soil which is removed. So you subtract them on both sides. If we assume WP nearly equals to WS prime, तो क्या हो जाएगा? WP अगर WS के बराबर ले लें तो ये कैंसिल हो जाएगा. अब क्या है, ये इक्वेशन आ जाएगा. WS बराबर किसके होता है? Gamma prime, which is unit weight of the effective unit of the soil, into volume of the pile, because equal to the volume of the pile you have removed, right, the soil. So AB into L. But you remember that gamma prime into L is the effective overburden pressure at the base of the pile. Effective overburden pressure at the base of the pile. Gamma prime into L into AB, you get this. Effective unit weight at the base of the pile. अगर नॉट को भी खत्म करें सिग्मा बी आ जाएगा. चलिए सिग्मा नॉट इस्तेमाल करें. तो WS की जगह you can write सिग्मा नॉट B प्राइम इंटू AB. अब देखें इसमें आप AB को you can take AB as common. You are left with this. Acha. One thing that I missed out, that QB is in terms of gross, right? Now QB gross minus sigma naught B is the net QB. So I can write PU is equal to QS into AS plus QB into AB, where QB gross minus sigma naught B prime is equal to QB, and QB is net end bearing pressure. Yeah, QB is the end bearing resistance and net is the net end bearing resistance. ये ज़्यादा अच्छा है. So the equation that you got is PU QS AS plus QB into AB. This is the equation that you can use to find PU. Very easy. Very easy. The only thing you want to find is QS and QB. Let's find QS and QB for sand. Let's find QB and QS for sandy deposit. For sand. QB. What would be QB for sand? QB for sand. QB is equal to, you know, that C and C plus gamma prime L into N gamma NQ. Instead of using gamma prime into D, which is depth of foundation, here you have L, length of foundation. This. Here you want to find QB, so this is the L. 1/2 gamma prime P. Instead of P, you would use D, diameter of the pipe, N gamma. This is the gross, actually the gross bearing pressure. And you want net bearing pressure, so sigma naught prime, sigma naught B prime. Effective overburden pressure at the base of the pile. In this equation, you see C and C, their resistance cohesion is zero, so this part becomes zero. Diameter of the pile is small, which makes this term as a whole very small, right? So this is also zero. You are left with only these two terms. And sigma prime into L is, you know, this is equal to sigma naught B prime. So you are left with only, and you can now take sigma naught B prime as common. So you are left with this. But NQ is very large. NQ की value large होती है, so NQ minus 1 is nearly equal to NQ. So QB is equal to sigma naught B prime into NQ. This is the simple equation for QB that we obtained from this equation. And what is NQ? You know this is bearing capacity factors. For pile foundation, it would be a bit different. For pile foundation, you can take NQ value from this table. For different values of pi, you have NQ for driven piles and you have NQ for drill or bored piles. Now QS. QS, skin friction resistance for sand, how to find them out? QS, skin friction resistance, is equal to cohesion, or you can say cohesion or adhesion. You can say adhesion between is between soil and pile material plus sigma average sigma prime horizontal stress, sigma horizontal into tangent delta. What is CA prime? Is adhesion between soil and pile material. What is delta? It is friction angle between soil and pile material. What is average SH prime? Is average effective horizontal stress long, or you can say effective horizontal stress averaged over pile length. Why horizontal stress? Because failure plane is vertical between pile and soil. So horizontal stress is perpendicular to failure plane. But in this equation you see, in this simple equation, you see, because this is sand, adhesion is 0, you got only this, and average horizontal stress, if you multiply this with lateral earth pressure coefficient, lateral earth pressure coefficient, you would average, sorry, yes, let me see. Sorry. This horizontal effective stress is equal to vertical effective stress to lateral earth pressure coefficient. So the equation becomes Qs is equal to A into average vertical effective stress into tangent delta. So if we know this value, we can find Qs. इसमें देखें delta की values are here. You can pick from this table. Ks you can pick from this table. Lateral earth pressure coefficient. And average vertical effective stress. Average vertical effective stress. So you got two equations for sand. One is QB, which is equal to sigma naught prime at the base, effective vertical stress at the base of the pile into NQ, and you got QS, which is K into average vertical effective stress into tangent delta. Using these two equations, you can find QB and QS, and then you can find ultimate capacity. Like PU would be equal to QB into AB plus QS into AS, right? So before going to solve a problem on this, I want to make a statement here. Here you can see both QB and QS increases with effective overburden pressure, right? As the depth increases, effective vertical stresses would increase, right? And QB and QS would increase. But experimental results show that vertical effective stress around the pile does not increase indefinitely with depth. Rather, after some depth, they become constant, and that depth is called critical depth. That depth is called critical depth. Here you see, this is the vertical effective stress, and it increases with depth, but when it reaches to ZC, which is equal to 15 times diameter of the pipe, after this depth, the vertical stress becomes constant. ठीक है? और जब ये constant हो जाए, so UKS and QS and QB would also remain constant. You see this? Here is another situation where you have a water table. So from here to here, you would use bulk unit weight to find effective stress. After water table, you would use effective unit or submerged unit weight, and when it reaches to 15 times diameter, after this it would remain constant. ठीक है ना? How can we find QB and QS from SPT test? For driven piles, this equation is given. Using SPT, you can find QB for driven piles. 40 into N55 into LB by B. Right? LB is the length of the pile, N55 is the SPT value at the base of the pile because you are finding QB. B is the diameter of the pile. You use this equation to find QB, but the maximum value of QB has to be 400 into N55. The value of QB should never be more than 400 into N55 kilonewton per meter square. Right? This is for driven pile. For board piles, you divide the value of QB by 3. 1/3 of this value should be used for board piles. QS for driven piles is 2 into N average. N average means N over SPT over the pile length जितनी आ रही है उसको एवरेज करें, उससे 2 को मल्टीप्लाई करें, you will get QS for driven pile. For board piles, you divide the value of QS by 2. You half it and use it for board pile. So we are going to use all these in example below, and that anything which is not clear to you, we hope that it would become clear to you. This is a problem. This is a problem. A 12-meter long pile, this is a 12-meter long pile, has a square section, ठीक है ना, उसका है स्क्वायर सेक्शन 305 mm, इसका क्रॉस सेक्शन है 305 by 305 mm. This is a cross section of the pile. ठीक है. We want the water table is at 2 meter. It is sand. Angle is 35 degree. Or delta is given to be 0.6 into 5 prime. Or lateral pressure coefficient is also given 1.4. Calculate the ultimate compressive load. Okay? So first you find, you know that PU is equal to QB into AB plus QS into AS. AB is equal to 0.305 into 0.305 meter square. नहीं यार कुछ तो हाँ बिल्कुल ठीक है. और AS is equal to 4 times 0.305 into L which is 12 meter. ये तो AB और AS हो गया. अब आते हैं QB की तरफ. QB is equal to sigma naught prime NQ. NQ की वैल्यू गिवन है 40 and sigma naught at base of the pile has to be found. For this, let's find the vertical effective stress. From this point to this point, the depth is 2 meter and the unit weight is 16.8. So 2 into 16.8 is 33.6. ZC occurs at 15 times width of the width of the pile at 4.575 meter. At 4.75 meter, the effective stress is 54.7. After that, it becomes constant. You see? So at the base of the pile, the effective stress is 54.7. So you have to write here 54.7. So what will be QB now? 54.7 into 4. That is in kPa. That is QB. What is the value of QS? QS you know is Ks sigma average sigma naught prime into tangent delta. Tangent delta we know that is 0.6 into 35 degree, which is phi value. Everything in this equation is known except average value of sigma naught prime. Average value of sigma naught prime is the area of this. This is sigma naught prime, so its average value is the area under this line divided by length of the pi. Here, see? Oh, so that is the see, by 12 मीटर. ठीक है, ये आपके पास सिग्मा नॉट प्राइम की वैल्यू हो गई. तो क्या है इसकी वैल्यू? इसकी वैल्यू देखें, यहाँ पे आती है सिग्मा नॉट एवरेज area divided by length is 46 kilonewton per meter square. You put all these values in QS. This is 24.7. Use this equation and the ultimate capacity is 575 kilonewton. So this is the solution of this problem. If you have any question, you can ask, so that I solve another small problem for you. Acha ji, let's solve a small problem, another small problem based on SPT value. Ali le pechi umar ki ali te wali na kalau mama shikoro ci palara wat ka ali te. Acha, you are given n at the base of the pile equal to 24. Let me solve it here. This is pi. At the base, you are given n55 equal to 24, and average n for the pi length is given equal to 13. The pi length is, I think, 9 meter, and the cross section of the of the pile is 0.45 by 0.45 meter. Okay? So we want to find out the capacity of this pile, and we have very good equation here. QB 400 into N, LB into B. N at the base of the pile is 24, LB is 9, B is 0.45, and 400 into 24. So this value is 9600 and this is 19.200. This has to be less than this, so your QB is 9600. QS value is 2 into N. N is 0. This is the ultimate compressive load capacity of the pile. If you are asked to find ultimate tensile load capacity, so remember that in ultimate tensile load capacity, you will not use the end bearing resistance, because when you are pulling the pile up, only the skin friction resistance would be used. So TU, which is ultimate tensile load capacity, is equal to AS into QS. This is a skin friction plus WP, weight of the pile, because when you are lifting the pile up, the skin friction plus weight of the pile would X on the pile. So this is the weight of the pile, and this is TU. You are already, the TU would be equal to 421, which is the skin friction resistance, and 42.8, which is 464 kilonewton. This is the last problem in for sand. Right? You solve that at home yourself. The solution is already there in a tabular form. The same equation of the SPT which we discussed are used in the solution of this problem. So this is the end of the lecture today, and now we will start the Viva. If you have any question, you can ask. Ibrahim Shah. Dalam mesin ni dia